Throughout the more than 100-year history of phonograph turntable technology, you really only have three ways, mechanical ways, to spin a turntable, a drive technology: direct drive, idler drive, and belt drive. 99.9% of turntables today are belt drive. We're going to look at one in a moment. We don't do any belt drive. I'll explain why. Direct drive would be things like the SP10, the system here or that there. And Techniques likes to say in their literature that they invented the direct drive turntable. But that's not quite true. Actually, the direct drive turntable was invented, and there may be ones that precede this, but this is a direct drive turntable from 1927. And if you look at this carefully, you'll see that each time the motor turns, the platter turns, one revolution. And this is an ingenious motor where this metal plate passes through, I guess this is kind of an induction thing, these two coils. And so every time this turns once, the platter turns once. It says Western Electric Croker motor. And this is from 1927. So this is actually the first direct drive turntable. All of the cutting lathes and all of the early professional turntables, all of them were direct drive. The problem with direct drive was that it was relatively noisy because the motors were so powerful. They had to be powerful because the system, the mechanical system that they were dealing with, was massive. So let's take a little look over here at such a direct drive turntable. So if you look around here, you're going to see a lot of big, impressive looking turntables. Most of them are direct drive turntables. In fact, this one, which we're in the process of restoring, was made by Fairchild, super rare, with huge motor and three big rubber belts that turned a flywheel. Very few of these were ever made. Why do we have all of these turntables? It's not because I'm interested in collecting turntables. There's one reason, and that is that if you want to design the best sounding turntable in the world, you had better know what came before you. You had better know what the engineering was back when everything was records, everything was turntables, and the best minds in the world were working on and designing these systems. You better know what those things sound like, how they were built, if you're going to make something that supersedes them. For example, this is an EMT 950. This was made for the BBC. When you moved the tone arm over the platter, and this is on, it actually has a groove indicator. It tells you what groove number your needle is in. This was so expensive, it probably cost as much as a Mercedes-Benz. This was an RCA idler drive turntable. I'll get to the idler drive next. This was the classic RCA 70D radio broadcast studio transcription turntable. These were made in the 40s, I guess up until the early 50s. Unbelievable, expensive, well-engineered, well-built thing. You'll notice that the platter is not a 12-inch platter. It's a 16-inch platter. This is obviously not a normal size record. Often in radio stations, this would be the playback arm. there might have been a lathe here, and if they were doing original programming, they would actually put a lacquer master and cut a recording of what they were broadcasting for posterity, for other stations. That was before tape, which came about in the late 1940s. So this turntable is a classic direct drive turntable. It's got an enormous motor like you might find on a washing machine, and a flywheel here, and these junctures to prevent vibrations from getting up into the platter and thus into the needle and into your speakers. But as you can see, one revolution, one turn of this motor system turns the platter. So direct drive means the motor and the platter, they're really one thing. So if this is such a superior method for driving a turntable, why don't you see this today? Well, look at how big this is. This was so expensive that even RCA didn't want to make these when idler drive turntables started to become popular. It was just the most expensive thing to do. And another problem is that this was a turntable that was made during the mono era, right? So mono, the recordings were lateral only. There wasn't any vertical thing going on in the groove. Now, the noise that this generates in the mono lateral direction doesn't register so well. But once you have stereo picking up this, you'd pick up more noise. So this would be quite a noisy turntable to use for stereo, not for mono. It's great for mono. This became essentially outmoded. Became outmoded because of this for home use. This is just I don't even know why we have this here, except I think it's really cool looking. This was a home turntable from the probably late 50s or early 60s. It was made by an American company called Record. It's a very, very nicely made piece of kit here. This is a belt drive turntable, and I'll show you how that works. We lift this off. Here's our platter. There's a nice little motor here, and here's the shaft of the motor, and a belt. It's really simple. Belt goes around the shaft, and it turns the platter. Big advantages to this: if there's any noise in the motor, the belt isolates it from the platter. If the motor is right underneath the platter and part of the platter, the noise goes right into the system. You can't have that. You have to have an incredibly expensive, precise, high-quality motor to have a direct drive turntable. Here, you can have a really cheap, simple, easy motor and a rubber band. That's all it is. This is what 99.99% of turntables use today. Doesn't matter whether they're $50 or $500,000. And yes, today you can spend $500,000 on a belt drive turntable that uses a motor that's actually made around this time. I'm not going to go into the people who make that, but pretty remarkable. We don't do belt drive turntables. Why? Because they suck. We do direct drive, or we do idler drive. This is a system that came out of the CBC in Toronto, Canadian Broadcasting. And as you can see, these are 16-inch decks. It's quite interesting to see the idler mechanism inside of here. You can see insane build quality. Okay. Direct drive turntables were the thing in radio broadcast and in studios. They were very, very expensive and big. And when idler drive technology started to become more popular after World War II, even in broadcast decks like this McCurdy that was made for the CBC, you started to see big professional idler drive decks taking the place of the direct drive decks. It's quite interesting how they worked. This is called an idler wheel. It's a rubber puck, and there's 3 on this, 1 for each speed, 33, 45, and 78. Here's the motor. The motor has 3 different diameter shaft points for contacting each one of these pucks. So as this is playing, because the platter's off, right, one of the pucks is contacting the motor, and the other end of the puck is contacting the inside of the platter. And that means that if there's any force that is slowing down the platter, the puck is caught between the platter's edge and this motor, which is a big, powerful motor, and it resists instantly. It resists being slowed down. And you might say, well, like, wow, this is this huge thing, big platter, big motor. Look at these pucks. Here's a typical tone arm from the time. What's going to slow this down? And the interesting thing about vinyl playback, whether it's from this period or even today, is that as the stylus is playing music in a groove, when it gets to a loud passage, for example, say somebody hitting the piano hard or loud rock music, those modulations, it's more difficult for this stylus to track that, and it slows the platter down. And if you don't resist that, what happens is everything kind of loses its pace and the transients don't feel as impactful. Basically, the music isn't as interesting to listen to. So what's really important in turntable design is not so much the absolute speed stability, which like a belt is fine with that. It's how well does the system respond to changes in speed at a very, very minute sort of amount in time. How quickly does it correct for speed? And that's what I want to talk to you next about with the direct drive turntables that we are now making.